Hello my dears, how are you all? So very good morning to all. Okay, so what we studied in the last class, we discussed some important single phase induction motor special electrical machines, and that was purely theoretical concept, my dears, because in examination and all there are some top points na lowest power factor motor, smoothest operation, lowest noise motor na, that type of question will be asked. So just to go through that only, okay, just to read and just feed it to your memory, that's all. No need to focus much on that special topic, no. And construction, lot of constructions are there for each machine, constructional details are there, but for examination point of view that is not important. For example, shaded pole machine, no, that is only just you have to know the idea, that's only, at least that special electrical machine I have taken the constructional detail, but rest of the machines are not that much important in construction wise, no. If you are preparing for a university examination, so the theory part will be asked from that session, but for competitive examination, no, the constructional details of special electrical machines are not that much important. So today we are going to learn a new session called the AC machines. That is, in AC machine we are dealing AC machine now. So in that we are going to deal synchronous generator or alternator. So where we are using alternator? Where we are using alternator? Suppose in power station, you imagine the case of our ejpdc substation, no, ejpdc is power station, not substation, power station. So substation also, there is a substation also in ejpdc, but consider the power station in ejpdc for power generation station. There we are using alternator. So alternators are also called AC generator. AC, alternating current or alternating voltage generator, is called the alternator. Or this is nothing but the three-phase generator. In DC generator, we got a three-phase, an AC, a DC from the machine as the output, but in the case of an alternator or synchronous generator, we get three-phase AC as the output. And why the name synchronous generator means, this generator is supposed to be run all the time with the constant speed, that is synchronous speed. It is not run less than that synchronous speed, that is why it is called a synchronous generator. That means its speed will be synchronization with the frequency all the time. If it is varying, then definitely it will come back to its normal speed or the synchronous speed within fraction of seconds by its own adjustments. Okay, that we will study later. So that is the main idea about the synchronous generator or alternator, and the main thing, the main difference between the synchronous generator and a DC machine is that in DC machine the stator was called the field poles, right? The stator was the field poles, but here the stator is the armature. The stator is the armature conductor, and here the rotor is nothing but the field poles. The field poles. That means compared to the DC machine, there in DC machine the field poles was stationary, and there was inside that stationary field pole or in between the stationary field pole there are what? Armature conductors which are supposed to be rotating clockwise or anti-clockwise direction. And here in alternator the field poles are rotation. The field poles are rotating and the armature is stationary, my dears. The armature here it is stationary. Okay, that means the conductors are supposed to be, or the conductors are wound on the surface of the stator, not in the rotor. In the case of DC motor, it was in the rotor. In the case of alternator or AC generator, it is on the stator side. And there is always, normally there are two type of alternator depending upon the rotor construction. So depending upon the rotor, there are two types of alternator. One is cylindrical and another one is salient pole. In thermal power station and all, we are using cylindrical rotor, and this cylindrical rotor it having very high speed rotor, normally in the range of 3000 rpm. And this salient pole rotor used in hydroelectric power stations, and they are low speed alternator. Normally 500 to 750 rpm. And we have the relation in AC or alternator also. The same relation you can apply as that induction motor. The same equation here also you can apply. That is, the speed is equal to 120 into F divided by P. And the cylindrical type alternator means the rotor is cylindrical in nature. That means simply, suppose this is the stator, the rotor will be simply a cylindrical structure. That is called the cylindrical rotor. Suppose the rotor is what? Salient pole type, my dear. This is the salient pole type. Suppose the rotor contains the poles projecting outward is called the salient pole. This is called salient pole. Because the poles are salient in nature. Salient in the sense projecting outward in nature. Cylindrical means it is simply a structure. So in salient pole alternator, I already told you, it is low speed alternator which is used in hydroelectric power stations, and the general equation for speed of the alternator is given by N is equal to 120 F by P. Suppose there is a two pole machine. You imagine there is a two pole machine. So 120 into F divided by 2. So it will be equal to 60 F. So if we get a standard output frequency of 50 Hertz, then what will be the speed? F is equal to, from this equation, F is equal to N by 60. So N to be 3000, then only, not 3000 my dear. So frequency to be 60 Hertz, 50 Hertz, this N will be equal to what? N will be equal to, or that is N by 60 equal to 50. The answer should be 50 when the N will be equal to 3000. So normally our alternator, suppose they are manufactured for two poles, the speed should be 3000 rpm. So accordingly, how many number of poles divided by that particular speed will, this relation should always satisfy with respect to the poles and the speed, because F here is a constant, it is always 50 Hertz in nature. Simply nothing, we always need a 50 Hertz supply, that's all. So accordingly you can adjust the poles and speed, that's all. Okay, whenever we increase in the number of poles, the speed will be reduced because it is opposite, not directly opposite, inversely proportional. N inversely proportional to P, that's all. And one more thing in this cylindrical and salient pole type, cylindrical alternators are used in and it contain normally very less number of poles, because in salient pole I already told you that it is a low speed alternator. If the speed is very low, means what is that? The P or the number of poles should be very, if N should be very high, means P should be very low. So in cylindrical alternator, cylindrical alternator, poles, number of poles should be minimum, say 2 or 4. Okay, but in salient pole alternator, since the salient pole alternator is a very low speed machines, it's a very low speed alternator, the number of poles will be very high. It will be in the range of number of poles will be more, say P is equal to 8, 12, 14, 16, 18, etc., 48, etc. So these much poles will be there for salient pole alternator, and there are normally 2 or 3 poles for what? 2 or 4 poles for what? Cylindrical type alternator. Then only speed will be very high. And the stator normally star connected. The stator of the alternator is normally star connected. Then only you will get a a neutral along with a neutral supply, because from the stator we are taking the output. Okay, so I will give you. So this is the general things about the alternator. Now we are going to move a very important session in alternator, that is a winding terminology. It is very difficult to understand winding terminology unless if you are not cared. Okay, if you really focused, then it will be easy. Not easy, that much easy. You have to revise 2-3 times, and only it will be in your fit to your mind. But anyway, this winding terminology is very important in AC machine. In the case of DC machine, simple lap and wave winding, that's all. But in the case of AC winding, so many factors are there, and we have to learn one by one. Okay, my dears. So this general thing, I think you already know this. That's why I not go to deeper. So stator is star connected, is very important. So let's see the winding terminology first. How can we wind the what? Stator or rotor? Stator or rotor, my dears? How can we wind the stator? Because in stator we have the what? Armature. The stator of the alternator is called the armature alternator. In the case of DC generator or motor, the stator is called the field poles, correct? So it's the reverse will be here. So this is the stator. Here we are inserting the armature conductors, and inside this there will be a rotor. So now we are focusing only on stator side. Okay, later we will come to the rotor and all. Okay, so this machine I already wound for that machine. This is a 36 slot 6 pole 3 phase alternator. What, my dears? 36 slots 6 pole 3 phase alternator, which means it's a 3 phase alternator. We will get a 3 phase output supply, and it contains 36 slots. The machine contains 36 slots. It's my wish that how much slot will be there, how many slots will be there. Okay, it's my wish. So I took just as an example 36 slots. So I marked slots like this. This circle is simply the slots, not the cross and dot. This external circle is simply the slots. So 1, 2, 3 up to what? I marked here as up to 36. Is it clear? And before that you have to learn one thing: electrical and mechanical degree. So there is a relationship between electrical and mechanical equal. Theta electrical equal to P by 2 into theta mechanical, or theta mechanical equal to 2 by P into theta electrical. This equation is very important in AC machine. So what is the meaning of electrical and mechanical degree is that mechanical degree means the degree that we can direct by our naked eyes. By our eyes you can directly measure, or the direct measurement system is called the mechanical degree system. Electrical degree we can't measure by using compass, by measuring directly. You can't measure that directly. Only by knowing the mechanical degree you can calculate the electrical degree. That's all. Electrical degree we can't measure. For example, the meaning of electrical degree is that we have, my dears, we have the R phase, the Y phase and the B phase. So we are saying that R phase and Y phase and B phase are 120 degree out of phase, or are 120 degree phase shift to each other. There, that 120 is called the electrical degree. There you are measuring that 120 degree now, that is called the electrical degree. That is called the electrical degree, not the mechanical degree. Okay, in the diagram you are measuring the degree now, that is called the electrical degree. Okay, so the degrees corresponding to direct waveforms are called the electrical degree, but the degrees corresponding to the measurement purpose, I mean we can directly measure, is called the what? Mechanical degree. Okay, and the relationship between theta electrical and theta mechanical is very important. This can be applicable to many cases, my dears. So this equation, even if you dream, if someone asks, you should answer. Theta electrical equal to P by 2 into theta mechanical to P2 by P into theta electrical. This you should always remember. So that is the electrical and mechanical degree concept. And next we are going to see how can we wind this structure. How I wound this structure? You already have a doubt now. Sir is already drawn something, and how can it obtained? Sir, sometimes it is cross and somewhere it is cross, again cross and dot, and A, B, C and all. What is the meaning of that? See, my dear, 36 slot 6 pole 3-phase alternator means, the 6 pole means phase A having 6 pole, phase B having 6 pole, phase C having 6 pole. That is the meaning of a 6-pole structure for a 3-phase machine. In DC machine, it is not that 3-phase now, it is simply a single phase and neutral now. So in that case, the poles means it is for it won't make confusion. But here in AC machine, poles means it is not the total poles of the machine. In winding methodology, my dears, in winding methodology, poles means it is not that much, means the total poles. It is for the phase, corresponding phases. In stator winding, in rotor, in salient pole alternator, suppose you are saying 1, 2, 3, 4 poles means it's 4 pole bus. So it is for the whole phase system. But in the case of stator winding, if someone is saying it's a 6-pole machine means 36 slot 6-pole 3-phase alternator means each phase having what? 6 pole. Each phase having 6 pole. That's, keep it in mind all the time. And let's see how can we wind phase A. Phase A winding. Let's see how can we wind phase A. See, my dears, I am starting my movement, I mean starting my winding, insertion of winding from slot number 1. Okay, so this is slot number 1. I started here, my first conductor for phase A winding, I started from here, that is phase A. And we know that the returning path of the phase A will be, of course, what? 180 degree electrical. Am I correct, my dears? We already know that the upcoming and the returning path between the phase A winding will be always 180 degree electrical. The ongoing and incoming conductor will always 180 degree electrical. It's very important, my dear. Electrical, it is always electrical, 180 degree electrical. So there should be always, suppose we are using three phases A, B, C. So A, B, C are the starting end of each phase. So definitely there should be a finishing end, right? That finishing end will be A dash, B dash, C dash. That's all. See, A, B, C and A dash, B dash, C that. Rather than that, if anything is seen here, no, it is full of contain A, B, C, A dash, B dash, C dash, like that only. These six terminologies are only there in the winding structure for a three-phase machine. Okay, so phase A winding I inserted in slot number 1. So A dash will be, so I can write like theta electrical between A to A dash equal to, what is that? 180 degree. 180 degree. Then is easily measurable by looking into the diagram? Theta electrical? No. We can't measure directly by looking into the diagram, because I already told you that electrical degrees we can't measure directly. Only mechanical degree we can measure directly and we can directly trace on the machine. Not electrical degree we can't measure directly. So here listen, my dears. So theta mechanical between A to A dash will be equal to what? We have the relation now. We have the relation theta mechanical equal to 2 by P into theta electrical. Am I correct? So it will be equal to what? 2 by P is nothing but 6 pole now. Theta electrical is nothing but 180 degree. So it will be 60 degree. 60 degree. So the phase A started from point 1 and its finishing end should be 60 degree mechanically away from the starting point. Okay, what is the 60 degree? What is the 60 degree means? Before that, there is another term you have to note here, that slot angle. Slot angle. It is represented by theta. Slot angle means this is a 360 degree total structure, my dears. This is a 360 degree total structure in which each slot carries or each slot occupied how much degree? That is called the slot angle. Slot angle formula is total slot divided by in total degree. Okay, what? 360 divided by total slots. So which will be equal to what, my dear? 360 degree divided by what? 36. So it is equal to 10 degree. So slot angle here is 10 degree. That is mean each slot, my dear, each slot, this slot is here now, this carries an angle of 10 degree. Likewise, this is carry 10, this carry 10, this carry 10. Total 36 slots carries an overall degree of what? 360 degree. That's the meaning of slot angle. That's the meaning of slot angle. So we have listen, we have the finishing end of the coil is nothing but the A dash. That should be finished 60 degree apart from A. This 60 degree is called the what? Slot angle, which is nothing but 10 degree. 10 degree means this is the 10 degree, my dear. So 60 degree mechanical away from this A will be the finishing end of the winding phase A. That means in coil 1, this cross means it is into the paper, no, into the paper. So I take a conductor and I wound into the slot. Okay, this is the slot 1. In slot number, in after how much slot I should take the outgoing conductor. This is the incoming conductor. After how many slots I should take the return path. That is nothing but after 60 degree. So the degree calculation, you have to take care of one thing. the incoming point na incoming slot, you not consider that by when calculating the degree. That means I will tell you that this is the incoming slot now. After that you start measuring 10, 20, 30, 40, 50, 60. And the outgoing is not the outgoing. It is actually taken from this slot. And that slot also you can't measure in terms of degree. So in between that two, the incoming and the outgoing terminals, only the angle you should measure. That are the angles represented by this. Okay, so by measuring angles you have to take care of one thing. First one is that you don't measure the angle of incoming and angle of outgoing. In between that only you can calculate, you can measure. Otherwise it will be wrong. Otherwise it will be wrong. Okay, so what here is that, listen my dears. So from the slot number 1 we inserted a phase winding A. After 60 degree you have to, in between A, the meaning of theta mechanical degree between A and A dash is that 60 degree means in between A and in between A dash there are 60 degree what angle subtended by these two windings. That is the meaning. Okay, so you inserted here 10, 20, 30, 40, 50, 60. So this 70 is actually the outgoing. So this 60 degree, this meaning of this 60 degree is that this one, this much covering. So this much angle you covered for getting the return path of the winding A. Is it clear? So where I started 1, I finished at 8. I finished at 8 my dear. I finished at 8. Is it clear? Is it clear? So that is for phase winding A. Next you can go for phase winding B. Phase winding B. We know that the electrical angle between there will be theta. Electrical angle between A and B is actually 120 degree. Is it correct? If it is a balanced 3-phase supply, the electrical angle between A, B, C are 120, 120, 120. You have to note down all these details because it will get to a picture. At least you should read it for 5 to 6 times or 5 to 10 times sometime. Then only it will be into your mind. If you simply look it won't get it into your mind. It is very difficult session. I'm telling you, it's very difficult session. 2, 3, 4 or 5 times if you revise it continuously, then only a picture will be there in your mind. Okay, this is happening. A picture will be there in your mind. So it is that much important, my dears. Okay. So this whole class is dedicated for this winding terminology only. Because if you don't know, I can simply skip this. I can simply go for what is pitch factor, what is distribution factor. I can give you some definition and all. In examination, the definition is enough for you, right? But as an electrical engineer, you should not perfectly know these things, what is exactly happening inside, but you should have picture. You should have an idea. Okay, this is happened. Then only our study will be worthy, na? Otherwise our study will be simply mug up and vomiting, right? It is not that, it's not good, right? So that's why I tried something. I'm trying something to deliver. Okay? After this you will have an idea of what is happening inside the machine of alternate, as an alternator or AC generator. What's happening inside? What is the winding means? Okay, you will get an idea. Okay, come back to a point. So we know that, my dear, the electrical angle degree between A and B is always 120. This 120, we can trace it? No, because it is electrical angle. We can't trace that. So before if you want to trace that angle directly by your eyes, or directly by a protractor, then what you should have? You should have mechanical degree. So the mechanical degree between A to B will be equal to what, my dear? 2 by P into theta electrical, which is equal to 2 by 6 into 120. So it will be equal to 40 degree. So meaning of that, the meaning of that 40 degree is that after you wound for phase winding A, you have to insert the winding B in 40 degree away from the winding A, which means, see, this is winding A, 10, 20, 30, 40, yes, correct. So 40 degree, that is in slot 5, you inserted the winding B, Is it clear, my dears? Is it clear? I will tell you once more after doing all this, okay? So please keep focused and keep calm. And this is the theta mechanical. So that means in slot number 5, we inserted the winding phase B, starting point at 5. Okay? The next step is you want to find the return path of B, that is nothing but the B dash. So, listen my dear, the electrical angle degree between B and B dash will be equal to what? We know that is 180 degree electrical. That is the incoming and outgoing, always 180 degree multiple. Always 180 degree electrical. A coil is moving here and a coil is moving out here and here. What is the angle between these two? It is 180 degree. Opposite, opposite. That is the meaning of 180. Okay. So the electrical angle between B to B dash will be equal to 180, or the mechanical angle between B to B dash will be equal to what, my dear? It will be 2 by P into theta electrical, which is nothing but 2 by 6 into 180 degree, or it will be equal to 60 degree. What is the meaning of that 60 degree, my dears? So in slot number 5, we inserted the phase winding B starting point. This is the inserting, so that is cross. This cross means current is moving into, and this dot means the current is moving outward. Or in terms of coil, in cross means we are inserting, dot means we are taking away, that's all. So cross means we are moving inward, and dot means we are taking outward, that's all. Dot means we are taking outside, my dears. Okay, so theta mechanical degree between B and B dash is 60 means, what is the meaning? So from B, you have to move 60 degree in order to get B dash. 10, so this is B na, so this is inserting, so you can't go for that. And next, what is that? See, B to B dash, so 10, 20, because each slot is 10 degree na. So this is 10 degree, this is about 10, 20, 30, 40, 50, 60. So is we take it 60 degree away? No. After 60 degree slot, what is the next slot? We take it outside. I already told you. Because we are inserting in 5, so that we won't count. So next to that 10, 20, 30, 40, 50, 60. Up to this means in between there are these much slots. These much slots in between. So we are taking after 60 degree, that is from slot number 12, we are taking away the conductor B dash. That means the return path of the phase winding B will be taken away at slot 12. And the angle between B and B dash will be 60 degree. That's all for phase B winding. That's all for phase B winding. Next, phase C winding. Phase C winding. Listen, in phase C winding, we know that, my dear, we know that the electrical angle between B to C will be equal to what? Electrical angle between A to B is 120 na. Electrical angle B to C also what? 120 degree. 120 degree electrical. So this electrical angle we can't measure directly now because it is in electrical term. So we have to convert it into what? Mechanical degree. So what will be theta mechanical between B to C? So it is nothing but 2 by P, that is pole P into theta electrical, which is nothing but, my dear, 40 degree. So after 40 degree from the starting point of B, what? C will be inserted. That means this is the starting point of B, my dear. After 40 degree means 10, 20, 30, 40. After 40 degree means this is the coil. So from 10 you can wound, or you can give the incoming coil or into the coil of phase winding C, Then where it will be the return path of C? That is the return path of the electrical angle between C to C dash will be equal to what? 180 degree. We already know the incoming and the outgoing, correct? The incoming and the, or moving into or the outward coil, between angle will be 180 degree. So we can't measure that 180 degree by using naked eyes or protractor. So we need to convert it into mechanical degree. So what will be the theta mechanical of C to C dash? It will be nothing but 2 by 6, that is 2 by P into what, my dears? Theta electrical is nothing but 180 degree. So it will be 60 degree. That means after we wound for the phase winding, starting end of phase C, after 60 degree only C dash will be taken outside. That means this is the into the incoming, na? That means this is the into coil, and this is the outward coil. This means outward coil, this means into coil. Okay, so slot number 9 is the into coil, my dears. No, slot number 8 is the, slot number 10 was the into coil, na? Correct? Slot number 10 was the into coil, na? So after 60 degree, na, B to C, so from B 40 degree, so this is from B 40, 10, 12, 10, 20, 30, 40. So this is after 40 means this is. So C will be equal to 10. So after this, after 60 degree from this 10th slot, we have to take what? 10, 20, 30, 40, 50, 60. Correct? So B to C means 40 degree. So B to C means 1, 10, 20, 30, 40. Correct. So in between B and C there will be 40 degree. Okay. And after means after this is the incoming current, right? So this also incoming. So after this we have to cover 40 degrees, 60 degree, 10, 20, 30, 40, 60. So after 60 degree only we will get the C dash. Cool. Okay, I will tell, relax. The phase angle or the angle between C to C dash is 60 degree means where we inserted C. We inserted C after 40 degree from B. Here B is nothing but here, my dears. Here was B, na? I already told you here was B, correct? So after 40 degree, 10, 20, 30, 40. After 40 degree means here. Here we inserted a point. Yes. After where I stop, phase C winding. Let's focus on phase C winding. Okay, I'm also confused. So phase B C winding should be wound from B after 40 degree. Phase C will be the starting end of the phase C will be wound after 40 degree from B. The B point was here. the B point was here. So after 40 means 10, 20, 30, 40. After 40 means after this only you can wind the phase C. Okay, 10, 20, 30, 40, correct. After 40 only you can wound for C means this is B, I mean only here we wound. So after that what? 10, 20, 30, 40. So 40 degree you will start C winding. So this is the C winding. Is it clear now? Okay, no confusion, correct. So this will be the starting end of C. That means in coil number 10 is the starting of C. Okay, and the incoming, I mean the C dash will be after 60 degree from C. That means this is C now. So after 60 degree means so C means it contains these and these. Okay, so in between angle measure the C dash will be 60 degree away means 10, 20, 30, 40, 50, 60. That means actually we inserted in coil this 10th coil now, the winding is inserted in coil number 10 because in between only 60 degree cover, 40 degree cover. This is the coil number 10. So after that you have to measure 10, 20, 30, 40, and after 40 only you can insert the winding C dash. Correct. After not 40, after 60. See, this is 10, 20, 30, 40, 50, 60. So 60 degree is the what? Outgoing of C dash. Is it clear? So like that, every poles are arranged. Every poles are arranged. Okay, so now it is phase A, B, C over now. Again phase A starts. Again phase A start from here. Again phase A start from here. Okay, and again the whole thing will be continuous. Again phase A start from here. Again the whole thing continues. Again phase A start. That means see A, C dash, B, A dash. Okay, A, B, A, C dash, B, A dash, like this arrange will be go on. A, C dash, B, A dash, C. Now this repetition now. See A, C dash, B, A dash, C, B dash. Okay, again A, C dash, B, A dash, correct na? C, B dash, okay na? Again A, C dash, B, A dash, A, C dash, B, A dash, C, B dash. See, 1, 2, 3 arrangement for 3 phases, correct. So 3 times you have to wind like this. So this is for your information only. Okay, now we are going to mention some terms in this winding. Terms in this winding. That is called the phase spread. One term is called phase spread. Phase spread. See my dear, here for a phase under one pole means suppose this is a 6-pole machine now. 6-pole means for each pole, I mean for each phase, suppose for A phase there will be 6 pole. So A phase there will be 6 pole means see A dash, A dash, and again A dash, see, A dash, A dash, A dash, which means A dash will constitute a north and south, a north and south. So two poles are there. There will be north, there will be south. Suppose in which this A dash, A and A dash, because in starting the flux lines will be started from the current. The current you can consider with the flux also, my dear. Suppose this is A, this is A dash. You can consider it as a pole because the current is moving into this, means there will be some clockwise flux now, some clockwise flux. Here will be moving away, means there will be some anti-clockwise flux now, anti-clockwise. So you can consider this as a pole pair. So A and A dash you can consider as a pole pair. So what happened? For phase A winding, there will be one A dash means north pole, south pole. A dash means north pole, south pole. Like that, for each phases there will be total 6 poles. That means for each phase there will be, for each phase A, B, C, 3 north and 3 south, 3 north and 3 south, 3 north and 3 south. In which manner we are arranged this? Okay, and phase spread means under one pole, my dear. Under one pole means just consider this line only. This is called under one pole, because A to A dash will happen only once now. So this is for one pole, under one pole for one phase, that means phase A. How much angle traced by the phase A winding, in consecutive slots. That is the meaning. In definition, I will write the definition so that it will be easy. Electrical angle by which, I will draw the definition. Electrical angle by which one phase winding for one pole is placed. That means the definition you know to remember, but the meaning you have to remember all the time. Nothing but for phase A, how many slots are there? These 2 slots constitute for phase A. These 2 slots for phase A dash. Okay, no problem. These 2 phase corresponding to a single phase, my dear. A single phase. So the angle subtended by these 2 slots are called the phase spread. That means electrical angle by which one phase winding for one phase is placed. One phase winding means A phase. Under one pole means under one pole. So one phase, so that means the phase A, the starting of the phase A. How much slots it covers? That's all the space spread. That's all the phase spread. How much slots is cover, my dear? 2 slots it cover. Mechanical degree means 10 degree plus 10 degree, 20 degree to collect. So phase spread means theta mechanical of the phase A, which is nothing but, my dear, it is called 20 degree. It is 20 degree. So the definition is give electrical angle by which, it is the electrical angle by which, so theta electrical will be equal to P by 2 into theta mechanical. So it will be equal to 6 by 2 into 20. So it will be 60 degree. So that is the phase spread here. That is the phase spread here. Is it clear? The phase spread means there is phase spread means in single phase how much adjacent slots are there for a single slot. That's all. Single phase. How many adjacent slots are utilized for a single phase? How many adjacent slots are utilized for a single slot? single space, single phase. Okay, there is an equation for this phase spread. Phase spread is equal to, my dear, slot per pole per phase into slot angle. Electrical, all in electrical. Okay, so slot per pole per phase is here what, my dear? 2. Correct. Slots are 36. Slot per pole per phase is what here? Slot are 36, pole are 6 pole, and phase is 3. So T is equal to 2. Clear? So that is the slot per pole per phase. So slot per pole per phase into slot angle. Slot angle here mechanically is 10 degree. Slot angle here is mechanically 10 degree. So what will be electrical slot angle? So it is mechanical slot angle into theta electrical will be P by 2 into theta mechanical, correct? So P by 2, P is nothing but 6 pole 2. So it is again 60 degree, you will get the same answer, that's all. So either by using the equation, no, in problem and all, this equation will help you. Slot per pole per phase into slot angle in electrical will give you the value of what? Phase spread, that's all. In physical meaning, for single phase winding, for single phase A, how much slots are covering? That's all. How much slots are covering for phase A? Here 2 slots cover for phase A. Phase A, slots are covering. Is it clear? So this slot angle combinedly, that is 10 degree plus 10 degree mechanical, 20 degree mechanical, converted into electrical degree. That's all will give the value of phase spread. Is it clear? Is it clear, my dears? I know it is somewhat difficult, I know that. Okay, is it clear? This is phase spread. Phase spread. How much spreading of a space happens? That's all, my dears. How much spreading of a single phase happens? Single phase happens. How much spreading of a single phase happen? How much phasing of a single phase happen? How much spreading? A single phase spreading is these two and under these two. Under these two it is opposite now. So under these two is the space spreading of phase A happens. Spreading of phase A happens in how much slots? That's all the slot. I mean space spread. That's all the space spread. Next, pole pitch. Pole pitch. Pole pitch. Listen, my dears. See, from pole means a starting end and a finishing end constitute a pole, correct? A starting end and a finishing end constitute a pole. So pole pitch, we will get you the definition first. The electrical angle traced by one pole under or for one pole for one phase is called the pole pitch. Listen, I will tell you in physical meaning what it is. See, my dear, phase A wound we insert in coil number 1. So after 10, 20, 30, 40, 60, after 60 degree the A dash will be there, na? A dash will be there. After 60 degree A dash will be there. So A and A dash will constitute a single pole. So pole pitch means, how much pitch means simply length. how much length is covered by a single pole. That's all the meaning of pole pitch. The electrical angle traced by one pole for one phase bus. That's all the pole pitch. So now the mechanical degree is 10, 20, 30, 40, 50. No? Yes. From here 10, 20, 30, 40, 50, 60. So after 60 degree, yes, this is the 60 degree. So after 60 degree, only the phase A dash is coming outward. So the pole pitch means from this A inserting point to the A outgoing point, how much angle traced, that's all. How much angle traced, that's all. From the point inserting, that is the one, to where the coil is taken outside, that is from 8. In between that, because A and A dash constitute a pole structure, correct? A pole structure. Because, okay, so in between A and A dash, how much slots are there, or in terms of angle, that electrical angle called the pole pitch. So in mechanical degree it is 60. It is mechanical degree 60. So we can say that theta mechanical between A to A dash will be equal to 60 degree. So what will be theta electrical between A to A dash? It will be theta electrical equal to P by 2 into theta mechanical. 6 by 2 into theta mechanical 60. So it is 180 degree. So 180 degree. Okay. Is it clear, my dear? So 180 degree here the pole pitch. 180 degree here the pole pitch. So I will tell you a trick. I mean, there is the equation also in terms of length. Pole pitch is equal to pi d by p. In terms of meter or in terms of length wise, you will get pi d by, if you get pi d by p, it will give you in terms of centimeter, meter or millimeter, anything depending upon the magnitude you will get in terms of meter. In terms of meter you will get the answer. And there is another equation that is, it is not that much important, 2 pi r by 6. This is very important, pi d by p. There is another equation 2 pi r by 6 where r is nothing but this radius, the radius of the machine, that is the r. Then also you can find the pole pitch. Okay. So in degree terms, the pole pitch means, simply my dears, phase spread means the angle between A, the angle between, or the how much angle A covers, that is the phase spread. Pole pitch means A to A dash, how much angle is covered, that's all. Pole pitch means A to A dash, how much angle is covered. Phase spread means a phase, that is a single phase. Phase A, how much slot it covers? Only 2 slot is covered for A. Pole pitch means A to A dash, how much angle it covered? A to A dash 10, 20, 30, 40, 50, 60 degree covered. Convert it into electrical, that's all. It will give you the answer. Bas. Okay, by knowing, it will be easy. If you know it for first time, it is the most difficult. If you know for second time, okay, somewhat okay. Third time, okay. Fourth time, oh, easy na. Fifth time, oh, this much easy. Sixth time, wow, super. This feeling you will get. This feeling you will get. It will take time. It will take time. So focus. Continuously do this. Definitely you will get. Definitely you will get. Okay. Is it clear, my dears? Next, full pitch winding. full pitch winding means if incoming conductor in slot 1 and or incoming in the sense I can say outgoing into or outgoing. Incoming means incoming towards me, outgoing means outside going, so this is I can cancel it outgoing. This is called outgoing. So outgoing I can take because the current is moving inward and out, and incoming conductor will be in what, my dear? Incoming conductor will be in what? This is the inward conductor or outgoing, where the finishing end or simply the starting end will be 1, where it will be the finishing end after 60 degree. We already learned that. So after 60 degree means 8. So it is in 8. Outgoing will be from 8. If this is strictly follows, my dear, if this is strictly follows for this machine, that means after 60 degree here it is nothing but, what is that? 60 degree means it is the pole pitch, correct? So after 60 degree, if the outgoing, incoming and outgoing conductors are connected, that means after we insert the conductor 60 degree we take the outside conductor, or from this 1 to 8 slot we are taking outside. This is called the full pitch winding. Full pitch winding. If we are taking the conductor not from this 8 but less than the 6, 7, 5, 4 or anything, that is called the short pitch. If the conductor take out from any slots rather than 8 is called short pitch. Is called short pitch winding. Okay, short pitch winding. And due to the pitching, that may be shorted some pitching, there will be a factor called pitch factor arise, and which is called Kp, which is called cos alpha by 2, which is called cos alpha by 2. This is very, very important. This sometimes, many times it is asked what is the pitch factor, where alpha is nothing but coding angle or short coding angle. That means, I will tell you, suppose this is coil number 1 and this is coil number 8. If this is exactly happen, this is called 180 degree. Suppose you take the for conductor number 7 as the output, return path, then the winding will be shorted like this. So this angle is called alpha, and this angle will be then not 180, it will be 180 minus alpha. Is it clear? So that is called the alpha or coding angle. That's the name is called coding angle or short coded angle. This is very difficult, I know. This is difficult, I know. Okay, but how can I tell? You want to study now? We want to study, so definitely you have to learn this. AC machines are slightly difficult than DC machine. So this is called a coding angle or pitch factor. Next one is distribution factor. Next one is distribution factor. Questions will not be that much difficult, my dear. The concept, these are very difficult. In examination and all, definitely you will build easy question. If you learn all these in examination, you won't stuck anywhere. guarantee. So next is distribution factor. Distribution factor. Before that, there are two types of winding, my dear. Concentrated winding and distributed winding. Concentrated winding means if slot per pole per phase equal to 1, that type of winding is called a concentrated winding, and if slot per pole per phase not equal to 1 or greater than 1 is called the distributed winding. In this machine, here the slot per pole per phase is here. Slot per pole per phase equal to what? We got 2, which means slots per pole per phase means total 36 slots. Slots per pole. For 36 slot, how many poles are there for 36 slot? So slot per pole means for each pole how many slots? 36 by poles 6, so 6. So there are 6 slots for one pole. And per phase means again divided by 3, which means there are 6 slot, not a 6 slot, there are 6 by 3, 2 slots for one pole and one phase. There are 2 slots for one pole and one phase. That means there are 2 slots for one phase under one pole. That's all. So this is called the distributed winding. That means if we insert an into the coil here also, here it is not contained the into coil, then it will form a concentrated winding. That means in one slot, my dear, in one slot for one phase only one winding. But here this phase A corresponding to 2 slots and 2 into conductors. So it is distributed, not concentrated. It is distributed among 2 slots. That's all. It is distributed among 2 slots, my dears. That is the meaning of distributed winding. And there is a factor again, due to this distribution of windings happens, is called the distribution factor. Distribution factor is equal to sin m beta by 2 divided by m sin beta by 2. This is the equation for distribution factor, where m is equal to slots per pole per phase and beta is equal to 180 divided by s by p. 180 divided by s by p, that is the beta. Okay, if you know beta and m, you can directly go for distribution factor and the value will be less than 1. This will be less than 1, and the pitch factor also less than 1. That's all. Pitch factor also less than 1. Actually, for distribution factor and pitch factor, there is a derivation, my dear. But we don't want derivation. We don't want derivation. We just remember this formula for pitch factor and distribution. There is actually you already derived. I think you would remember this. What I say in Malayalam, a viscery structure, a viscery like structure. Viscery like structure there will be there for winding, and you have to calculate this pitch factor and distributor factor from that. But derivation we don't want. We just want the physical meaning and problem. How can we apply that? So is it clear, my dears? Is it clear? And why we are using this distribution as well as pitching? Short pitching means in order to reduce the harmonics, my dears. In order to reduce the harmonics. Even though the EMF is reduced by using this pitching and distribution, but we will get a sinusoidal, nearly sinusoidal waveform without or not that much harmonics. So by eliminating the harmonics, we are using the pitch and distribution. Okay, so that's all for today. So let's meet again with a new session on tomorrow. So bye.